Hello and welcome to this episode of Curiosity Labs Between Two Nerds, where every week we invite a small human being on to have a little chat with us about science. This week's small human being is...
Mohammed. I am 8 years old.
8 years old.
Very good.
Are you enjoying being 8 years old?
Yeah.
Yeah, it's the best time of your life.
It is.
Yeah,
It is.
so
Make
far.
sure you enjoy it.
Yeah. And you know the nerds, I'm Mo.
And I'm Eugene.
Okay, Mohammed, what would you like to talk about?
Who discovered the Big Bang?
Okay, good.
The Big Bang.
The Big Bang Theory. So discovered, yeah, so who came up with the Big Bang Theory? So you know what the Big Bang is, right? Jonah, what is it?
Well, it's when the universe started.
Good, very good.
With a chemical reaction.
So something started it. It started from this moment, which we call the Big Bang, right? So there was a time when our universe was squeezed, everything in our universe was squeezed into the tiniest little dot. That's what the theory says, right? And something happened, and from that, the Big Bang happened, and everything else exploded out of it to where we are now, right? So who came up with this theory? I think first person to kind of suggest it was Lemaître. I don't know if I'm saying that right, but that's...
Lemaître.
There you go, with the French accent, right?
Apologies to anyone French that's watching.
So I think he's the first person to suggest it. But then Einstein's theory of general relativity, right? So his theory, although Einstein didn't suggest it himself, but if you use his theory and you kind of rewound the clock back, it would suggest that there was this moment, right? The Big Bang. And then really there's another astronomer called Edwin Hubble.
He's famous.
Yeah, who kind of then discovered some of the evidence that kind of started to prove this theory. And then there's Fred Hoyle, who had this final bit of evidence, experimental evidence that you know what, this is now the leading theory of how the universe started. So Lemaître really started it all off.
You said it wrong again.
Yeah, no, I'm not gonna try.
Give it a go.
So that's, he would have discovered. But you know why? How?
Yeah. What was the lead clue?
Yeah.
How did he come up with the theory?
Very good. Okay, so now I think how he came up with it, though, was because of just taking Einstein's equation. Is he before that, though? Okay, so taking Einstein's theory of general relativity, which is our theory of gravity, basically, right? And kind of running the clock backwards on that to see what would have happened in the past. I think that's how he came up with this theory. But the real experimental evidence for it, I guess, was... So when astronomers were looking at all the galaxies that we can see. So when you look up at the night sky, not from a city like this, and so in a city, we only can see a few stars, right? But if you went out into, let's say, the desert, and you'd see way more stars. Now, some of those stars aren't actually just stars; they're entire galaxies. So, how many stars in the galaxy?
100 billion.
Yeah, something like that, right?
A lot.
So it's actually what you're looking at is 100 billion stars together in a galaxy, just really, really, really far away. Okay, so some of those points of light aren't just a star or planet. They're like billions.
I think
of stars.
Andromeda's the easiest one to see.
Yeah.
Which I think there'll be places, I think you can see it with the naked eye. You could easily see it if you're in the right place with the telescopes. It would look like a star, effectively, but what you're actually looking at is 100 billion stars clustered together, forming a galaxy.
And if you look at it through a telescope, then you'll see, like, actually, wait, it's a bit more happening there. Yeah.
So that one dot in the sky.
Yeah, it could be.
Yeah, it could be so there will be a dot in the sky that you look at, and it's actually a galaxy, not a star.
Yeah.
So you're looking at 100 billion stars in one dot. That is a great face.
Yeah.
You need to go out and do this.
Mind's blown.
Yeah.
So and then if you, so now if you look through a telescope, you might see more detail. Like you might see like kind of like you'll see it might have a slightly different shape that would suggest that it has these spiral arms. Like, have you ever seen like pictures of the Milky Way galaxy? No, they're not actual pictures, right? But have you know what galaxy is supposed to look like, right? With all those little bits coming off it, those arms. Yeah. Okay, so you might see that, or like if you look through the Hubble Telescope, which is up in space, you'll see it in even more detail. Now, these astronomers, when they're looking at all of these galaxies, they started noticing that all the galaxies were pretty much moving away from each other. Okay, so what they thought that, okay, so now let's say we did the same, astronomers in 100 years were looking at these same galaxies, so they would be further away, right? So they started thinking like, okay, what would astronomers have seen 100 years in the past? What do you think? Where would the galaxies be? Would they be further away, closer together? What do you think?
I think closer together.
Very good.
Yeah, so they would be closer together. And if we went back another 100 years, where do you think?
In one galaxy?
Yes. At one point, maybe not 100 years, but if you keep rewinding the clock, the galaxies, right, since they're moving away from each other now, they must have been closer together in the past, right? And now, then they use some math and all these other science bits, and they realize that if we rewound the clock 13.8 billion years, so that's 13, 8, and another 8 zeros after it, right?
Yeah.
It's a huge number, right? If we rewind the clock back that far back, all these galaxies would kind of be on top of each other and squeezed into this tiny, 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 tiny region of space. Well, no, it's not region of space because there's no space yet. But yeah, so they're tiny little dots. And so what it suggests is that something happened 13.8 billion years ago, and everything that we see now has come out from that moment. Got it? Yeah.
So in simple terms, everything's moving apart if you rewind the clock. So if you're watching that in forward, it just keeps moving apart. If you're watching it in backwards, it all comes down to this tiny little thing where it all began. Yeah. As far as we know, it's where it all began.
Yeah, so, yeah. That cool?
That makes sense?
Yeah.
You should, based on your mind being blown about seeing that one little dot that's a galaxy, if you haven't already, you should look at something. It's a really famous picture called Hubble Deep Field. It's the Hubble Telescope, named after the scientist we mentioned earlier. And it's our best telescope, and it's in space.
For now.
And I think they spent about 11 days looking at a patch of space, kind of tiny little patch of space, where we knew nothing. There was nothing visible. We couldn't see anything. So they focused the Hubble telescope on this tiny little patch of nothing for about 11 days, and then looked at the images they got. And you should Google that image. And every dot you see in that image is a galaxy containing about 100 billion stars. And this image is amazing. So it will blow your mind.
Yeah.
It's cool. And you definitely need to go out and find Andromeda with a telescope. You'd love it.
Yeah.
So
like you get like on a phone, you'll get these apps that if you point it up at the sky, it'll tell you what you should be So all these lights, all these little things that look like stars, when you actually look, it'll tell you what they are. So some of them, so the second brightest thing in our sky, star that you'd see is actually Venus. It's not a star, right? So after the moon, then the second brightest, the next brightest was Venus. And then you'll be able to see Venus.
Have you seen Venus? You can. So Venus is on show right now in Dubai. So in the evening, I don't know where you live, but if you face, say, let me think, north So that's west. So roughly speaking, west in the
see
evening, and you'll look, and there'll be one super, super bright star in the sky. So do it this evening, and it's not a star. What you're actually looking at is Venus, the planet.
Yeah.
It's the hottest one.
No, it's not actually because it's the hottest, but think about distance from us. Which planets are closest to Earth?
Well, Venus and Mars.
Yes, and so Venus and Mars, they're our neighbors. Venus is actually much closer to us than Mars is, right? So that's why it's brighter, because it's so close to us. And the moon is obviously closer.
Yeah.
So that's why that's brighter. Yeah, so Venus. You can even see Mars. So you'll actually, if we look up at the night sky, you might see one of those stars will have a slight red color to it. Very slight red color. And that's Mars. And you can see Jupiter as well, which obviously doesn't look as big. But then if you get even a very simple telescope and you look at Jupiter, you'll be able to see like the bands. So you know what Jupiter kind of looks like, right? It has these bands on it and a big red spot. With a basic telescope, on a good day, you might even be able to see that the big red spot. Now, you wouldn't see that color, but you'd be able to see like a dark ring circle on Jupiter and these tiny dots around it, which are its 4 largest moons. Okay, so these are the things that Galileo actually, have you heard of Galileo? Yeah. So these are the things that Galileo saw, because he's one of the first people to look through a telescope, and he saw that with Jupiter. And if you look at Saturn, now that's the best one. If you look at Saturn, you actually can see the ring around Saturn.
One time you showed me a picture.
Yeah, I did. Yeah, so through my telescope, I used my phone and I shot it, and then you can see like the ring around it. Now, it doesn't look like a ring, so what Galileo called them were ears, because they kind of look like ears, right, around Saturn. So that's what they called them first. But yeah, those are the rings of Saturn, and it's amazing.
So everything from the planets to other galaxies to all the stars in our galaxy.
Yeah. So even with like a pretty basic telescope, you can see that from. That's pretty cool, right?
Have you got a telescope?
Are you gonna get one?
When's your birthday?
Soon.
Well, it's in June.
That's pretty soon. That's pretty soon.
Yeah.
I'd start my bidding now for a telescope.
Yeah.
Make sure
And
that
you don't even
behavior
need like
is perfect.
a really big one, like just a simple telescope, and you'll be able to see some amazing stuff. And you'd have to go out to the desert, though.
Which is cool.
Yeah. And but so any other questions? I think.
Well, I did go to the desert
Yeah.
on New Year's.
Yeah.
So if I
perfect.
had a telescope, I could.
Yeah, you
see.
could have seen it. Yeah,
Absolutely.
Actually, and that time, winter in Dubai, so around this time is probably the best time because it's a lot more clearer. The air around you is clearer. There's less humidity, so it's a lot easier to see. I have a big one. Maybe one day I could do a little field trip.
Yeah.
Have to
Curiosity
do
Lab
it.
field trip to the desert.
Yeah. You'd have to be awake pretty late though.
Yeah.
Past
All
bedtime.
right. Late night adventure.
Yeah.
Like once in a while.
Yeah. But we actually have even better telescopes in orbit around the Earth. So the problem so we have amazing telescopes here on Earth, right? So usually you would have these up in the mountains because problem is when you're looking at stuff through the atmosphere, it doesn't give you a clearer image because of all the air around us. So the higher up you go, the less air you're going to have to look through. So usually like in places like Hawaii and in South America as well, up in the mountains, they have these really amazing observatories, right? With big, huge telescopes that unfortunately it'd be cool if you could look through them, but most of them they just take pictures, right? And but if you go up into space, now you can see things more clearly because there's just no atmosphere around you. So we have this amazing telescope that Eugene mentioned, the Hubble Telescope, right? Which is orbiting around the Earth, and we're pointing it at different parts of the sky.
I did read a book on the Hubble.
Oh, there you go. So,
Perfect.
yeah, but very soon they're going to launch an even better one called the James Webb Telescope. And yeah, so it's going to be much more powerful than the Hubble Telescope. Yeah.
That's exciting.
Yeah.
So you can see more.
Yep.
Yeah, see more. Yeah. And also, when they actually look at stuff through the telescope, they don't just use the light that our eyes are used to. They use all the different types of light. I think we talked about some of them, like ultraviolets and infrared, right? Remember? Yeah, so that we use all these other types of light because then we can see even more stuff around. Yeah.
Because ultraviolet can reveal more things.
Yeah, it can. And some things, like some stars, may not be giving off any visible light that our eyes can see, but they could be giving off infrared light or ultraviolet light. So to our eyes, they would be invisible, but to a telescope or even an animal that can see that kind of light, they would see that big
An animal
giant
with a
star.
telescope.
Yeah, with the telescope as well, right? But yeah, so they'd be able to. So we use different types of light when we're in these telescopes and radio waves, actually. Yeah.
It's pretty cool.
I didn't know radio waves had
Yeah.
anything to do with space.
Well, radio waves are a type of light, right? Yeah, we didn't do the whole spectrum, I remember now. Yeah, but if you keep going, so there's even more types. So there's infrared, ultraviolet, then there's microwaves, right? Like a microwave oven, right? So microwave oven uses microwaves inside it, right, to cook food. But microwaves themselves are a type of light, and then there's radio waves, which are a type of light as
But
well.
you can't see the microwaves because they're
You
micro.
can't. Yeah.
It's true.
They're actually, for light, they're bigger than most types of light. I don't know
Longer
why.
waves.
I think it's because it's in the micro, the wavelength's in the micro. I think it's 7.5 centimeters, I think, half a wavelength. Anyway, then there's X-rays as well. You've heard of X-rays, right? And gamma rays. These are all the different types of light.
Avoid the gamma rays.
Yeah, or even ultraviolet,
Yeah.
even X-rays. All right.
Stick with visible. Let the
yeah.
animals do the rest.
Yeah. Another question?
Well, not really.
You don't have to.
I thought you wanted to know about how the hottest stars.
Yeah.
Yeah, you did, right? Unfortunately, I know you asked this before. I don't know what the hottest star is.
No.
Yeah, but stars get much, much bigger than our sun, like way bigger. Right? Like our sun is a very average size star. You know what average means?
Yeah,
Yes.
like normal.
Yeah, like normal. Yeah.
Normal star.
Yeah, like in the middle. So you can have stars that are much smaller, well, less massive than the sun. And you can have ones that are way more massive than the sun. So our sun is like pretty much in the middle, right? And the only temperature I know of the sun is like the surface of the sun is about 6,500 Kelvin.
The
Celsius.
surface of the sun is the same temperature as the Earth's core.
Yes, where did you learn that?
Well,
In a previous Between Two Nerds episode, I think, right?
actually, I learned it
Oh, no.
before the podcast.
At Curiosity
started.
Lab.
Yeah. So the core of the planet, the inner core, is the same temperature as the surface of the sun, which is about 6,500 Kelvin or Celsius. Yeah.
There's some potentially cool stuff happening right now. So again, it's a good time to, well, hopefully still in June, get that telescope. So there's a star, and it's much bigger than our sun, and it's a famous star, and it's called Betelgeuse.
Yeah.
And it's about 650 light years away. So do you know what that means? It means it would take light, the fastest thing in the universe, 650 years to get from that star to us. Now, and we've noticed over the last months, years, that it's starting to change shape, and it's starting to look very, very different. So, well, I'm hoping that at some point in the near future, and it probably already has happened, that it'll explode. And that would be a great time to have a telescope. And that's happening right now. Well, I say right now. Might have happened 650 years ago, so it's all relative. But if you have a telescope now and you can find Betelgeuse, you're looking at a star, same as our sun, but way, way bigger, but it's starting to lose its shape. suggesting something exciting might be happening. Another reason we should all get telescopes.
Yeah. Cool. Yep. All right, Mama Dessert. Did you enjoy that?
Yeah.
Yeah. That was awesome. Great questions.
High five. Will you come on again?
Yeah.
Perfect.
Good.
Now, very important. Oh no, before we do the ending, do you think people should subscribe to this channel?
Yeah.
Have you subscribed to this channel, or have your parents subscribed? Let's hope so. But if they haven't, you can tell them there's a little bell button down there somewhere. And very good to get those notifications. If you've got a comment that you're desperate to reach out to us with, don't hesitate, write it down below. If you're listening on the podcast, please rate us, please like us, please star us, do all those good things.
Just spread the word.
Spread the word.
Right. Tell your friends.
Yeah.
Yeah.
And tell your friends to tell their friends.
Well, on my science fair, I wore
Yeah,
the
I saw
lab
you.
coat.
I did. He just had a science fair and he did an amazing presentation with vinegar and baking soda filling up a balloon.
Oh, brilliant.
And he presented it very well.
And did you have your Curiosity Lab coat on?
Yeah.
Very
Well
good.
done. Well done.
Good
Free
job.
advertising that. Well done.
We'll take it.
Right, now you need to stare this time into that camera and wave profusely. Thank you very much.